Welcome to my online class. In my last video, we talked about, we are looking at a problem on composite bar. We looked at how to calculate for the force that is developed in the bar, or let me say in the rod, sorry. Now today, we want to continue with our question, how to calculate for the compressive force. How to calculate for the what? The stress that is what imposed in the bar due to that force. How do we do that? Please, before I start, please don't forget to subscribe to my YouTube channel for more videos. Now, let's get started. From here, we are given that the E is equal to 6.0 gigapascal and alpha is 100 times 10 to the 6. Our change in temperature is 30 degrees, which is increasing, don't forget. Now, in my previous video, we calculated the area to be equal to 1,963.5, which is the area of the smallest thickness, while the area of the larger thickness is 4,417.86 mm. And our force calculated is 51.6 kilonewton. Now, today we want to look at the maximum compressive stress. Now, note something. In my previous video, I said something. The total deflection of the bar should be equal to 0. But the bar is subjected to different deformation. That means formation of the bar is different. But the forces due to this constraint is equal in both bar. Now, since the force is equal in both bar, but there are different deformation of the bar, and also the thickness of the bar are different, automatically it's going to give us different stress. Whereby the stress that will be imposed in this, that will be developed in this smaller thickness, will be different from the stress that will be developed in this larger thickness here. Please note something. According to our listing, we know that stress equals to force all over area. It simply shows that when there is an increase in area, there should be a decrease in stress. In other words, when there is a decrease in area, there will be an increase in stress. Now, the question on board said calculate the compressive force, calculate the maximum compressive stress, the maximum compressive stress in the material, the maximum compressive stress in the bar. Now, we are going to look between point AC and CB. Which one of them will be subjected to what? Maximum compressive stress. Depends on their area. If you take a look at this point, area of AC is 1,963.5, while the area of ACB is what? Of CB is 4,417.86 millimeter square. This is square. This one also what? Millimeter square. Now, it simply shows from the area that AC will be subjected to what? High compressive stress than CB. Don't forget that both of them will be subjected to compressive stress. But the stress of AC will be more than the stress of what? CB. Now, how do we now go about it? From here, I can easily find it that what? The stress, the maximum compressive stress C, will be equal to the force in the member all over the area. So the force in the member, given to us is 51.6 kilonewton. Now don't forget that my stress is equal to force all over area. Now the maximum compressive stress sigma C should be equal to N over A, whereby United said the maximum weight stress is found in AC. Now, my N given to us is 51.6 kilonewton, divided by 1.6 kilonewton divided by AC, which is 1963.5. Now, from here, before you calculate for your stress, don't forget that stress is always measured in Newton per millimeter square, or is given as mega Pascal, because 1 Newton per millimeter square is equivalent to 1 megapascal. Now, I can easily convert this my force back to Newton, whereby I will be having my sigma c to be equal to 51.6 times 10 raised to the power 3 all over 1963.5. Now, this should give rise to 51600 divided by 1963.5. My maximum compressive stress that will be imposed in the material should be given as 51,600 all divided by 1963.5. That should give rise to 26.28 megapascal. 26.28 megapascal. These are to calculate for the stress in the bar material. Now, if you look at the third question that is there, they said we should calculate. How do we calculate for the deflection of point C? That is the third question that we are given. Calculate for, or let's say the deflection of point C of point C. Find the deflection of point C. How do you find the deflection of point C? Don't forget, I have my area of AC to be equal to 1963.5 and my area CB to be equal to 4417. Okay, that will be given to us later. We'll be calculating for that later. I have the force N to be equal to 51.6 kilonewton. Now, we have to calculate for the deflection of this point C here. How do we find the deflection of point C? Please note something. You see, the deflection of this point C will be caused by the parts that has high compressive stress. That means the one that has what the maximum compressive stress is going to produce high deflection. It simply shows to calculate for the deflection of point C, we try to make use of the part of the rod with the lowest thickness. That means the deflection of point C is due to the rod AC. Thereby, to get the deflection, I'm going to calculate for the thermal stress, that means the deflection due to thermal stress, due to what change in temperature of rod AC, and also the deflection of this same point C due to this compressive stress that is imposed on the bar. Now, how are you going to do it? In this case, to find the deflection. Now, deflection of the bar due to change in temperature should be given as alpha change T into L. But in this case here, don't forget I said something that what? Both of them are subject to what? Compressive. But this point C will be deflected due to these points, this stress, because this one has high stress than this. Now, to calculate deflection of this point C here, then I can easily substitute from here my alpha, my change in temperature, and the length of points AC. Now, since my alpha is equal to 100 times 10 to the power minus 6, my change in temperature is equal to 30, and my length AC is equal to 225. I can easily calculate for my deflection in that place 100 times 10 raised to the power negative of 6 multiplied by 30 times 225 to give rise to 0.675 ml. Now, this is the deflection of point C due to increase in temperature. Now, calculate the same deflection that is caused due to the stress that is developed in the member. Namely, to calculate deflection due to the stress developed in the member. Don't forget something. that the stress in a member is always equals to Young modulus times strain imposed in the member. Now, stress equals to Young modulus times strain, and strain is equals to deflection of the member over length of the member. Then I can make deflection formula here. My deflection should be equals to stress times length. My length in this case is length AC over Young modulus. Now, in that case there, I should be having what? The stress, which is the high compressive stress that is there, the maximum compressive stress there, that is the length AC over Young modulus will be equals to what? Now, the maximum compressive stress in this material is 26.8 megapascal, whereby I should be having my deflection due to the stress are 26.8 multiplied by the length AC. Length AC is 225. Everything all over 6.0 times 10 raised to the power 3. 6.0 times 10 raised to the power 3. Please don't forget, in my previous video, I explained to you the reason why this is 6.0. Why? This is given to us in gigapascal, but we have to solve in megapascal. Now, I'll be having this to be equal to this. 26.8 times 225. That should give us 630. 6,030 divided by 6,000. That should give us 1.005. 1.005. Now, to calculate for the total deflection of point C, don't forget initially I said the total deflection of the bar must be equal to 0. Now, deflection of the bar, that means total deflection of point C due to a change in temperature, dt minus d. We are going to find the deflection. Sorry, initially I said what total deflection due to the whole bar should be 0. But once we wait for deflection of point C only, to get deflection, we are going to subtract, because normally there is an increase in temperature. So this deflection due to temperature is a kind of an increase in positive deflection. While the deformation due to what? The stress. See, the stress is compressive. For a compressive stress, we know that what? A compressive stress is always a negative stress. Now, since stress is compressive, the deformation here should be what? Negative. That means deformation should be what? Compressive. Normally, the total I should have, that means since the stress is compressive, deformation should be what? Negative. I should be having dt plus d. But since my d is negative, I will be having dt 0.675 now plus d, which is minus 1.005, which will give rise to 0.675 minus 1.005, which will give rise to 0.33 mm. 0.33 mm. That is my deflection of point C. So therefore, the deflection of point C, the C equals to minus, sorry, this is negative, minus 0.33 mm. That is my deflection. Thanks for watching.